activity 3, the easy way to think about it, because sometimes you need a little bit of a push. In fact, most groups did. But all I did, if you remember, really, I mean, all I really did was this: A, B, C. I just added those 3 letters to the triangle. That was enough for pretty much every group to get it. I also said, okay, can you now write sine theta equals what? So somebody help me out. Which in this case is B over C. So if there was a group that didn't get to activity 3, the next step is write another thing that's equal to B over C. Because equivalency is all about things being equal. If 2 things equal B over C, they equal each other. And don't forget, an identity does not mean like in one case they're equal, but in all cases they're equal. So for all angles, the 2 statements have to be equal. For example, sine of 45, or in grade 12, pi by 4, is equal to cosine of pi by 4. But that's like not really an interesting identity. That doesn't mean sine theta equals cos theta. That's one example of a place where they're equal, right? One example only. There are lots of others, but identities are where it's true for all values of the variable, all angles. Does that make sense? Activity 4 seems the hardest to understand what it's asking you to do, but really what it's about is the quadrant angle formulas. So if I want to get to quadrant 2, I do pi minus theta. Quadrant 3 is pi plus theta. Quadrant 4 is 2 pi minus theta. And you can think about the equivalency. So sine would be easy for this one because it's sine theta will be the same. Somebody tell me sine theta will equal what? Oh, come on. They're both positive in the top quadrants. So what's another way of getting to this angle? I just told you. Sine, of pi minus theta. Those will be equal. Do you agree? Because of everything you do with angles in standard position, all the understanding we have for that, those would be equal. So easy to do for sine. You would need to add more to it to do cosine because cosine is negative in quadrant 2 but positive in quadrant 3. But you can account for that with one simple little thing that you would add to the formula to make them equal, right? So this wouldn't be true. Cosine theta would not equal cosine of pi minus theta. But how could I make the left side equal the right side? How could I do that? No, I don't. I'm going to let you think about that. I don't actually want an answer. I want everybody to answer that on their own. Like you could add something very easily to one side or the other of this equation that would make them equivalent. Here's the next thing that I would challenge you to do tonight. It's kind of in the practice, but it's important regardless. We got this with our understanding of angles in standard position. Now could you think about it in terms of transformations and think about how they're equivalent? Like in your head or on a piece of paper or with graphing software, could you take this statement that we already know is equal and think about what are the transformations happening on the right side that makes it turn back into sine? I'll give you a hint, you'd have to factor because this isn't arranged properly. But if you factored it and you wrote it out and thought about the transformations, if you do this, you'd better get a graph that looks exactly like sine. Is this a question or are you answering? Go for it. I would do it until you feel like you could do it for anything. Do you understand what I mean? So same thing with the cofunction identities, which are these ones, the pi by 2 minus theta. I could do the same thing. We thought about this one in terms of triangles, and everybody's light came on as soon as they saw, oh, right, of course, B over C. Gosh, I get it. Now apply it to transformations. Can you do the same thing, but not with the triangle, with transformations? There's even a question, it's really hard, That's not question number 6 anymore because I changed the order. I think it's question 4 on your handout with the diagrams, where you do it with angles in standard position. It's a hard one though. Question 4 is optional. If you do all the rest of the worksheet and you want to do the one with the 2, even one of them with the diagrams on that sheet, like if you're looking to be a top student, push yourself, those are really good questions to think about. Megan, did you still have a question? Oh, tan. If you have time and you want to explore it, you could. You don't have to at this point. Sorry, I thought you were asking about cosine as well. Just tan. No, you don't have to worry about tan. Okay, we got to get to this. So how do we apply this? Write an expression equivalent to each of the following. I'm going to add 2 little restrictions. They should already be on here. I don't know why they're not. Where 0 is less than or equal to theta, less than or equal to 2 pi. And we're going to, for cosine, I guess we're not going to do tan. We'll just do 1. Yeah, we won't worry about tan for now. For cosine, we're going to do both a cos and a sine. One of them's easy, one of them's a bit harder. So if I wanted to come up with another equivalent expression for cos, what could I do? Anybody have an idea, John? Why 2 pi minus? Oh, very good. John got the right answer first off. He skipped the easy answer and went for the hard one. So he's right. 2 pi, this is what we just talked about, minus pi by 8 will be equivalent. And what is 2 pi minus pi by 8? Because we can't leave it like that. We need to simplify it. So that's 16 pi by 8 minus 1 pi by 8, which is 15 pi by 8. Is 15 pi by 8 in that domain? Yes. It's not smaller than 0. It's not bigger than 2 pi. We subtracted from 2 pi. We're good. The easy way is if I just added a period. Because if you add a period to any periodic graph, you're back where you started. So cos of pi by 8 plus 2 pi is everybody's favorite easy answer to that question. But that would put us outside our domain. So if you have a restricted domain, there's a very good chance you will not be allowed to just add a period. That's too easy. I want to push you harder. What's the other way that we could do it? Well, I know that cosine is even. So cosine of pi by 8 will be equal to cosine of negative pi by 8. Right? Right? If you don't know that, think about that overnight again tonight, because that's a really important idea. That's true because they're even. But negative pi by 8 is also not in our domain. So unfortunately that, although better than just adding a period, still wouldn't really qualify. Okay? Sine, how am I going to do it? I'm going to use sine of pi by 2 minus theta, where theta is what I started with. So that's sine of pi by 2 minus pi by 8. And then I'm going to solve that again and reduce it properly. And that's going to give me an answer in my domain always. So changing cosine to sine or sine to cosine is pretty easy because you can always use the cofunction identities, which is this. That's called the cofunction identity. So switching between them is always, but doing this one is the harder one. So that's 4 pi by 8, half, right? Minus 1 pi by 8, so that's going to be sine of 3 pi by 8. Use transformations to explain the following. Oh, is that the one we were just looking at? Oh, no, it's not. Yes, it is. Yes, it is. Yes, it is. Isn't it? Yeah. Right? We were just looking at this one. Perfect. Okay? We only have 1 minute, but I want to show you, so I'll do it for you. Oh, I'll even do this part. Okay, so left side equals sine of pi minus theta, which is equal to sine of negative theta plus plus pi, which is equal to sine of negative bracket theta minus pi. So I'm shifting it to the right by pi and a reflection in the y-axis. These are the transformations we're performing on this. Is that everybody okay with that? So I'm going to shift it to the right by pi, and then hold on, reflect it, and isn't that sine? Just look at it. That's sine. That's sine theta. It's the same graph. Okay. Good luck.